Hello, good evening, ladies and gentlemen. You are warmly welcome to Octogona Library. Today we are looking at different subjects. Today we are looking at physics. And under it, we are looking at velocity time graph. Let us look at the question. A car starts from rest and accelerates uniformly to a velocity of 40 meters per second after 8 seconds. It maintains this velocity for 10 seconds and comes to rest in 7 seconds. Draw a velocity time graph for the motion and use it to find the A, acceleration of the car, B, the total distance traveled by the car, and C, the deceleration of the car. So let us look at it. We have to draw a velocity time graph. And on the velocity time graph, we will have our velocity on the y-axis and our time on the x-axis. So let us just make a sketch. In fact, this is going to be a sketch. We are not going to use a graph sheet. So say that it is from rest to 0. So let us see how to scale the velocity. The velocity, let us make it 10, an interval of 10. So 20, 30, 40, 50. Right. Remember to indicate that this is the velocity. This is when we scale our velocity. Then our time. Time is in seconds. So let's scale from there. Question 8 seconds, 10 seconds. So we can scale it to 5, 10, 15, 20, and then 25. Good. Now the car accelerated uniformly to a velocity of 40 meters in 8 seconds. So I am going to go. In fact, the car was at rest, meaning that it began from velocity 0, it was not moving. So it accelerated until 8 seconds. So this is 10. So my 8 will be somewhere here. So let's see my 8. So this is going to be the motion of the car when it was accelerating. Good. That is it. Then it maintained the velocity for 10 seconds. So if this is 8, 10 seconds, for 10 seconds, the car was not accelerating. It was moving with a uniform velocity. So this is how it is going to be. We go like that. So for 10 seconds, so it was moving 10 seconds until here, 18 seconds. Go from 8 to 18, that will be 10. So we go here. Then what happened again? It maintains this velocity for 10 seconds and then comes to rest in 7 seconds. So from 18, in 7 seconds, 7 seconds from 18 to 25. So it came to rest in this time. So that is our velocity time graph, but we must indicate that, okay, let us name the vertices because if you observe, we have formed a very nice trapezium. So let us indicate the vertices A, B, C. Let us put D here, and then let us put E here. So yes, this is our velocity time graph for the motion of the car. So this solves the A part of the question. Let's look at the B. The B says that we should use our graph to find the acceleration of the car. Acceleration A is given by the final velocity minus the initial velocity divided by time, the time taken for the acceleration. So what is our final velocity? The car began from rest. So our U is 0. Our U is 0 meters per second. Then our V is 40. That is the final velocity. So V is equal to 40 meters per second. Then in what time? Time is equal to 8 seconds. 8 seconds. Therefore, my acceleration A is going to be 40 minus 0 divided by 8. And this will give me 40 divided by 8, that is 5 meters per second squared. That is the acceleration of the car. 40 divided by 8, and that will give us 5 meters per second squared. Good. B says that, that was A, sorry, that was A. B says that we should find the total distance traveled by the car. The total distance traveled by the car. Now, looking at this diagram, the trapezium, you would see that it has been partitioned into 3 segments or areas. Let me say areas. So let us indicate this to be area 1, this to be area 2, and that to be area 3. Now we say that the area under the curve of a velocity time graph gives the total distance traveled. So I am going to calculate area 1, calculate area 2, and then area 3. Then when I finish, I put them together. And that will give me the total distance traveled by the car. In fact, that is one method. When we finish, I will use another method to find the total distance. So let us use first area 1 is equal to, and area 1, if you observe, is a triangle OAE. And once it is a triangle, its area is found by saying half times base times height. So area 1 is going to be half times the base, and the base is OE, and that is 5. 5 times the height. The height is 40. And when we calculate this, that is going to be, that will be 8 rather, because it is up to 8, sorry. That will be 8. That is 8, because from here to there was 8. So that is 8. 4 times 40, and because half of 8 is 4 times that will be 160 meters. Then let us find area 2. Let us find area 2. What will be area 2? Area 2 is a rectangle. You see A, B, D, E. So area of rectangle, area 2 will be the length times the width. So that is going to be the length is 40, then the width will be 10, because it is from 8 to 18. So that is 10, and that is going to give us 400 meters. That is area 2. Then let's look at A3, area 3. Area 3 is going to be half times the base, and the base is from this side, which is 18 to 25. That is 7 times still. The height is 40. And when we calculate this, that is going to be, let's say, half times 40 is 20. 20 times 7 is 140. 140 meters. So the total distance traveled. So total distance traveled is A1 plus A2 plus A3. So what did we get for A1? 160. 160 plus A2, we had 400. 400. So plus A3 was 140 meters. And when we put all of this together, we are going to get 700 meters. So the total distance traveled by the car was 700 meters. We can find it by another method. This is a trapezium. An area of trapezium, in mathematics, we know area of trapezium, let's say area of trapezium O, A, B, C. O, A, B, C, yes. It's given by half times the sum of the parallel sides. And when we look at the parallel side, we have AB plus another parallel side is OC, times the height, and the height can be either AE or BD. So let's use A. So let's see, half times, what is AB? AB is the interval between A and B. So that will be 10. From 8 to 18, that will be 10. Plus OC. What is OC? OC is from 0 to 25. So 25 times AE. What is AE? AE is 40. So 40. So the whole thing is going to be half times 35 times 40. And when you calculate this, you are going to get 700 meters. So indeed, in calculating or in finding the total distance the car traveled, you can use either the partitioning method, where you find the individual areas and put them together, or you consider the entire area under the trapezium and all of the two formulae. When you use them, it will get you to 700 meters. That is correct. So let's look at the C. The C says you should find the deceleration of the car. The deceleration happens from here, from B to C. That is where the car begins to come to rest. So that is also acceleration, but this time it is negative. So we say that it is beginning from this side. So we consider our initial velocity to be 40, because this is where it begins to decelerate. So our U here is 40 meters per second. Then our V, and our V is the final velocity. Our V is the final velocity, and that will be 0, because that is where the car will come to rest. So that is meters per second. Then at what time? It did so in 7 seconds. So it means that acceleration or deceleration is 0 minus 40 divided by 7. And that is going to be negative 40 over 7. Let's compute that and see. Negative 40 divided by 7. That gives me negative 5.7 meters per second squared. Remember, it is the negative of acceleration. Deceleration is the negative of acceleration. So the deceleration of the body was 5.7 meters per second. Thank you very much. Make a date with me another time so that we look at more physics questions under motion. Thank you very much.